Alright class, here's our review for tomorrow's test. Now these first few problems, all you're going to do is find what is the value of x. So right here, let's subtract 7 because we want to get x by itself. So 7 minus 7, that's 0, cancels out, so I get x equals, what's 21 minus 7? 14. Say number 3. Well, let's start by getting rid of the number that does not have a variable, the 10. Let's subtract 10 from both sides. Get 5x is equal to 20. Divide by 5, because now I want to isolate the x even more. 5 times x is the same as 5x. The opposite of multiplication will be division, so I divide here and I get x is equal to, what's 20 divided by 5? 4. Okay, so right here this is a two-step equation, one-step equation. Should not be too difficult. Now if you're having difficulty with those, of course you can ask for help. Come in the morning after school, or watch this video again. And there's also previous videos that we work on the same thing. How many solutions does each equation have? Now, real quickly, if you end up with something that looks like it's mirroring itself like 3x equals 3x, or even 0 equals 0, so you cancel everything out, that would be infinite. Okay. If you end up with something like 3x equals 5, well, I'm sorry, not 3x equals 5. Say your final answer is x equals 5. Then, since you're able to solve it to where it's only one number, one possible number that can work, one number, one solution. Now, if you have something, say, let me erase all this, like 3x plus 5 is equal to 3x plus 12. Well, let's get rid of the 5 first. I end up with 3x equal to 3x. Now you might see already, like, wait a minute, when I get rid of this 3x, I get rid of the other one. So I end up with 0 on this side. Just cancels out, and 7. Can 0 ever equal 7? No. Since I say no, no solution. So, since we can't find a solution for it, there's no solution. So if we look at these right here, we have 2x minus 5 is equal to negative 5 plus 2. Well, one thing I can do is, I had mentioned before about switching positions. I can rewrite this as 2x minus 5 is equal to, I can put the 2x first, 2x minus 5. I could even start solving this and say add 5, they cancel each other out, and I get 2x is equal to 2x. That's infinite. Now right here, let's subtract 2 from both sides. 3x is equal to x plus 18. Now let's get rid of the x. 2x is equal to 18. Divide by 2. X equals 9. Since I found one answer, one number that works, one solution. Now right here, is this a solution for the system? Well, here's my x, here's my y. So wherever I see y, I'm going to put an 8. So I'm going to rewrite both of these down here, okay? So, 8 and 8, 3 and 2. So you see I'm rewriting them as I go. Now, they both have x. What is x? 1. This is plus 5, plus 4. So I rewrote them already. Now, when I work this out, it should equal 8. 3 times 1, that's 3, plus 5, 8. That works. It's true. 2 times 1 is 2, plus 4 is 6. False. Or I can X them out. So this means that the first one is not a solution. So, same thing here. 12, 12, 5 times 2, 3 times 2, minus 7 plus 2, 10 plus 2, 12. So that works. 6 minus 7, negative 1. Whoops. Again, it's going to be not a solution. Okay. So, since we have the ordered pair, we can answer these. When we don't have the ordered pair, well, we have to solve for one or the other and then figure out, okay, does it work? Now, right here, we're given the ordered pair. We just check, does it work? It does. Great, solution. Doesn't work, not a solution. And it has to work for both equations, okay? They both have to work properly. Now, right here, how many solutions does this have? Well, if I ask myself these questions, it'll help me to answer this. How many times do the lines intersect? If they do not, if they're parallel, will they ever intersect? No. So, no solution. So no intersection, no solution. If they intersect one time, let me get red right here, because they have one point where they cross. One intersection or one intersecting point, one solution. So where will we see infinite? Well, let me draw a little graph. Now let's say I have a line. Then I graph another line, and it's right on top of it, like this. Well, something like that. If they're the same line, if they're on top of each other, it's infinite, because they will always be touching each other forever. They'll always be intersecting because they're on top of each other. And since these lines have arrows, that means they keep going forever this way and forever that way. And they continue to intersect. Okay, so right here, this problem earlier on the board did not have these numbers. Where do I get those numbers from? Well, where do they intersect at? 4, 3. So I get 4, 3. Then I plug it in. 3 is equal to negative 4 plus 8. 3 is equal to x, which is 4, plus 2. This gives me 4. Already I can tell it doesn't work, so not a solution. So if you see one that has a graph and you have a system like this one right here, well, where do I get my ordered pair? From right here where they intersect. Now right here we're given the same thing as before. I'm going to rewrite these as, well, I'm going to rewrite them and plug in x where I have x and plug in y where I have y. Now x equal to 2, so that's 3 times 2 and 2 plus a negative 2 minus 3 times negative 2 equal to negative 4 equal to 4. This gives me 6 plus a negative 2, which is 4. So this one is true. 2 plus 6 is 8. False. So that's not going to work. So it's not a solution. Okay, so again, we have the same thing here. Now, I'll go ahead and skip this one, and let's look at this one, which says elimination. Now, during elimination, we're going to add straight down. And when we need to, we can multiply an entire equation by a number or by a negative, so that way we can change the signs, so that way we can cancel out either x or y, and we can solve for one of those variables that's left over. Now, when I add straight down right here, negative x plus x, that's like x minus x, that cancels out. Then when I add right here, y minus 5y gives me negative 4y. And then right here, 5 minus 9, negative 4. Let's divide by negative 4 on both sides. Y equals 1. So I don't get lost, let me write my first part of my ordered pair, y equals 1. Now let's take either equation and plug in y and then solve for x. So I have x minus, you know what, I'll use the first one. Negative x plus 1 is equal to 5. Subtract 1. Negative x is equal to 4, but let's divide by negative 1 because I don't want to leave my variable as a negative. So this becomes positive x. 4 divided by negative 1 becomes negative 4. If I want to double check my work, I can go ahead and plug it into the first one. Excuse me about that, I'm about to cough, but I guess I didn't. So negative 4 minus 5 times 1, and I don't know why I'd use 2 sets of parentheses. This becomes negative 4, negative 5 times 1 becomes negative 5. When we combine two negatives, their negativity increases, and it's true, it works. So I can double check my work. And number 15, same thing. I end up with 2x. This cancels out. This becomes 14. Divide by 2, First part is 7. Now, let's take that 7, plug it in where we see an x, and we'll get our solution. 7 plus y equals 12. Right here you might be able to look at and figure out it's 5. If not, we subtract 7 from both sides, y equals 5. There will be some problems that we have to use substitution. I'll make a video on that later, and I'll have some problems that are substitution type problems, and those will be extra credit. So if you have any questions on any of these, come and see me after school or in the morning, or watch this video again. Post a question. I'll usually get an update saying someone commented, and I usually follow up pretty quickly. Okay? So any help that you need, come see me, okay?